Welcome to the fourth installment of this Unreal Engine 5 tutorial series where we build a smart enemy AI system inspired by the Xenomorph AI from Alien Isolation. In the last video, we covered a complete beginner's introduction to state trees. In this video, it's finally time to start building our enemy AI character. The goal of this lesson is simple. Create our NPC enemy character and implement basic rudimentary movement behavior. By the end of this video, we'll have created our Alien NPC character that will be the focus of the rest of this series, an AI controller that will govern the various systems of behavior and perception, and finally a state tree that we will add to our AI controller via a state tree AI component. The project files for this video will be made available to download from Gumroad completely for free. However, if you would like to support the work that I do, please consider supporting this channel by making a donation via the Buy Me a Coffee link in the video description below, or by adding a monetary amount in the Gumroad link if you choose to download the project files. As always, if you enjoy the content, please like the video and consider subscribing to my channel. And with that out of the way, let's get started. Now, before we begin, I'm just going to add some content from our third-person template, and the reason being is because I find it is sometimes easier to debug certain things from a third-person perspective. So we'll go ahead and add that now. We'll go down to our content drawer and just go to our top content folder and then click the add button and then add feature or content pack, and then we will select the third-person content pack and then select add to project. This may take a few seconds to add. And once that's been added, we can go ahead and close the open content drawer and the add content window. And we'll open up our content drawer and we'll go into our third person folder and open up the third person level. Now I'm going to create a copy of this level. So I'll go up the top and select File, Save Current Level As, and then we will go into our Tute content folder and create a new folder and call this Maps. Double click that. And we'll call this LVL_prototyping. And now that we've got this new level saved, we will likely be using and expanding upon this level in many of the future videos now. So what I might do is I'll go up to Edit and Project Settings. And we'll go to, under Project, we'll go to Maps and Modes. And I'm going to set this new level we've created as the editor startup map so that it always starts at this level when opening the project, LVL_prototyping. And we'll go ahead and close that. And now it's finally time to create our Alien NPC character. And we're just going to copy the third person character and make a few modifications. So what we'll do first is go to the content drawer, into the Tute content folder, create a new folder, and we'll call this Blueprints. Open that up, create a new folder again, call this Characters. And then what we will do is we will just expand in the side menu here and then go back to our third person blueprints folder. And we will drag and copy the third person character into that new characters folder. So we'll click and drag into characters and select copy here. Go back to our characters folder. We will highlight the character, press F2 to rename. And then we will call this BP_NPC_Alien. Now let's just modify this character blueprint a little bit. So we'll double click it to open it up. And the first thing that we're going to do is just get rid of all these player controls codes, hit delete. And then over here in the function section, we'll select the move function and delete that. And the aim function and delete that also. There's also an implemented interface here, which we will also get rid of. So we'll go up to the top and select class settings. And then under implemented interfaces, we will click this X. And then it's going to ask if we would like to transfer these functions into the event graph to make them a part of this blueprint. We'll just select no. And that'll get rid of that blueprint interface. And now finally, we won't be needing a follow camera because this is an NPC character. So we'll delete the camera and also delete the camera boom. Compile and save. Now let's just change the appearance of our character. So we'll go over to the viewport and then select our mesh from the components panel. And then I'm going to use the Mani mesh. So we'll go over here to the skeletal mesh asset, click the drop down, and we will use SKM Mani Simple. And then finally, just keeping in line with the alien's color theme, I'm going to change his color material to black. So what we'll do here is we'll go over to the material section and click this button to browse to the asset. We will select both the materials, right click and duplicate. First, we'll open up the first material that we duplicated, and then under paint tint, we will select the color and then just drag this value all the way down to black and select OK and then save. Go back to our content drawer, open up the other material that we duplicated. And this one's a little bit different. We just need to tick the paint tint button here and then select the color and then drag down to black, hit OK and save. And then finally, we'll go back to our character, open up the content drawer, select the first material, and then we will click this arrow to assign the material, and then do the same for the other black material that we created. Great, so now we've got a basic character that we can expand upon in the series to come. Now let's go ahead and create our alien behavior state tree. So we'll go over to the content drawer, go to our Tute content folder, blueprints. We'll create a new folder and call it AI. And we may create some AI for some other NPC characters in the future. So I'm just going to create a new folder here and create a folder specifically for the alien. And we'll go inside there. And finally, we'll create a folder for state trees. And now we will right click, go to artificial intelligence and create a state tree. Now in the previous video, we mainly focused on the state tree component, which can be added to any actor that can be placed inside the world. But this time we're going to create a state tree AI component, which can be added to an AI controller. This will give us access to many of the features and functions of an AI controller class. So we'll go ahead and create a state tree AI component, and we will call this st_alien_behavior and double click that. So as discussed in the previous video, the AI component schema gives us access to the context actor class, which by default in the AI component is set to a pawn class, because a pawn is a type of actor that can be controlled by an AI controller. For our context actor class, we could leave this as a generic pawn actor. However, we want to access custom functions and variables within our NPC character, so let's go ahead and assign the context actor class to BP_NPC alien. And compile and save. Now we also want to assign a custom AI controller class. So let's go ahead and create our first AI controller. Let's go down to the content drawer and we'll go back to our alien folder and we'll create the AI controller in here. So we'll right click and select blueprint class. And for this, we want to search all classes AI controller and select this one here. So as per the description, an AI controller is the base class of controllers for AI controlled pawns. Let's select that and click select. And we will call this AIC for AI controller _ NPC _ alien. And let's open that up. Now, an AI controller class is not a type of actor, so it can't be placed inside the world. Because of that, we won't be needing the viewport. So if that opens for you, just go ahead and close that. And let's go to the event graph. Now, unlike the player controller, which depends on human input to determine actions and behavior, the AI controller operates autonomously by processing environmental data and game state information. Another very important feature of the AI controller is that it does give us access to the AI perception component, which will allow us to gather information about what our character sees in the world, what it hears in the world, damage that it receives. All of this information is accessible via the perception component, which we will discuss in the next video when we discuss sight perception. But now that we've covered a brief overview of the AI controller, let's go ahead and add our state tree AI component to our controller. So we'll go over to the components panel, click add and type in state tree, and this time we will select state tree AI component. And now with that component selected, we'll go over to our AI section and implement our state tree alien behavior, and we'll make sure that start logic automatically is enabled, compile and save. Now, one other thing that we need to do is we also need to assign this AI controller to our NPC character. So we'll go back to our alien character and then click on class defaults at the top. And in the detail panel, we will type in AI controller. And then for AI controller class, we will assign our AIC NPC alien, compile and save. And one final thing we need to do before implementing behavior is let's go back to our state tree and assign our custom AI controller to the AI controller context. So we'll click on that and select AIC NPC alien, compile and save. Now we're finally ready to implement some basic rudimentary behavior. I'm going to create our first state and I'll call this search. And if you wish, you can add a description to your states. So I'm going to add the description: agent does not have attack target. Enter. And once we add a description, it will add a speech bubble icon, which we can hover over to read the description. Now I'm going to create two child states of our search state. I'll right click, add state, add child state, and I'll call this MoveTo random location. We'll right click search again and add another child state, and we will call this wait. I'm also just going to create a color scheme for our search state, call this search. And for our color, I might do a bright green. It's good. Highlight all of our states and add that to search. Now what we're going to do is we're going to create a custom state tree task to get a random location in the world that our NPC will navigate towards. Now in the previous video, whenever we created a state tree task, what we would do is select new task and then select state tree task blueprint base. Now the downside of doing this every time we create a task is then if we need access to our actor and our AI controller context in each of those tasks, we have to add the variables each time to each task that we create. It would be easier to create our own custom base task. So what we'll do is we will select state tree task blueprint base. We will go to our alien folder, create a new folder, call this ST tasks. Go inside there, and we will name this task ST task underscore alien underscore base task, and then click save. Now that we've created that, we're going to create a variable for our actor context. So we'll add a new variable, call this alien character ref. This will be of type BP NPC alien, and then object reference. And if you remember from our last video, we will add the special category context to automatically bind this reference to our context actor class. And now we will create another variable, and this will be our alien AI controller ref. And this will be of type AIC NPC alien object reference. And now that we've already created our context category in this task, we can now select the dropdown and just select context, and this will automatically bind the AI controller context to this variable. And of course, just to improve readability, we will go to class settings, and under blueprint category, we will type in Alien NPC Behaviour. And then under blueprint display name, Alien NPC base task. Compile and save. And now that we've created this base task, for every task that we need to implement for our NPC alien, we can now create a child of this class, which will already contain these variables ready for us to use in each task that we create. So let's go to our content drawer and into our tasks folder. I'll just create a new folder for the child tasks, and I'll just call it tasks. Now, to create a child of this, we can either go back to our state tree and select new task, and we can simply select our Alien NPC base task, and this will create a child of this task. Alternatively, we can also simply right-click the task in our content drawer and select Create Child Blueprint Class. And I will call this SD task alien get random location, and I will just move this into our tasks folder, and we will open that up. And you'll see we already have our context references ready to be used. So let's go ahead and create an enter state event. So we'll select override and then enter state. And when we enter state, we want to get a random location in the world. So let's select our alien character reference as a get variable, drag off and select get actor location, and we'll simply right click in the event graph, and we want to use get random location, and we want to use this one here, get random location in navigable radius. In navigable radius just means that the location that we output can be navigated to within the world and within the navigation volume, which we'll discuss shortly. So we'll hook that up to event enter state, and our origin input will be our alien character's current location. Now, radius here refers to the radius in which the location will be obtained from. So for example, if we set a radius of 1000, that means that it will get a location within a 10-meter radius of our origin point, which is our actor's location. If we set this to 500, it would output a random location within a 5-meter radius. Just to make this a bit more flexible, I'm going to promote this to a variable. I'll call this search radius, and we'll expose it to the editor so we can simply set the search radius from within our state tree editor. We don't need to worry about any more of these inputs here. But now, once we get a random location within our defined search radius, what do we want to do with that random location? Well, what we will do is we will create a parameter. We'll go back to our state tree, and over here under parameters, we will create a new parameter. This will be of type vector. A vector is a location within the world based on 3 axes, an X, Y, and a Z. We will rename this vector to point of interest. And we will now update this parameter in real time using our task. So we'll go back to our task that we're working on. And if you'll remember from the previous video, in order to update a parameter in real time, we need to make use of a special variable. So we'll go ahead and create a variable. We will call this point of interest param. And the variable type we need is a state tree property reference. Select that. Now, we can't select the reference type until we compile the blueprint, so we'll go ahead and compile. And now we'll select the reference type, and it will be of type vector. And we also need to make sure that we expose this to the editor so that we can bind this variable to our parameter. We'll go ahead and drag that into the graph. I'll hold down the control key to automatically create a get variable. Then we'll drag off and select get property reference, hook that up like so, and we'll make use of the set by ref node, which, as you recall from the last video, can set a variable based on an input reference. So we'll hook up the reference to target, and that will automatically change it to a vector set node, and we'll hook that up to succeeded. And the value that we want to set will be the output of our random location. Hook that up like so. And then once that parameter has been set, we will drag off and type in finish and add a finish task node. And just in case our get property reference fails, we'll drag off the failed and type in finish again. And this time mark succeeded as untrue. And one more thing actually, before we move on, is we'll go to our class settings. Under blueprint category, We'll add the category Alien NPC Behaviour. For some of these things, because we'll be adding this category multiple times, it's sometimes good just to keep it on a plain text file so that we can just simply copy and paste it as needed. And then for the blueprint display name, we will change this to get random location. Compile and save. Now let's go back to our state tree and let's implement this task on our move to random location state. So we'll select that state, and then under tasks, we will add a task. And under Alien NPC Behavior category, we will select Get Random Location. And it's here that we can set our search radius if we wish. I will keep this at a value of 500. And just remember that we also need to bind this variable to our parameter that we created. The state tree will not compile if we do not bind this. It will give us an error. So we'll just select this binding. And then under global parameters, we will select point of interest and then compile and save. So now in our state tree tasks, it will execute first at the root, and then based on our selection behavior, which is select children in order, it will select the first selectable state, which is search, which has no tasks. So this acts as a selector state. Again, based on that selection behavior, it will select children in order. So it will move to our first state, which will run the get random location task. Now what we need to do is we need to create a task to move to that random location. We've got the location now. It's been updated in our point of interest parameter. Now we need to actually move our NPC character to that location. We will keep this in the same state, and we will add a new task. And under action, you will see an already pre-built task called MoveTo. We will select that task. Now, our MoveTo task has a number of things that we can assign. For destination, we can input our own destination manually if we wish, or what we will do is we will bind it to our parameters and then point of interest. And we will hit compile. And you'll notice an icon has now appeared here under the move to random location. This icon will appear when the state contains at least one task that ticks at runtime. So why has this icon been added now after binding our parameter? Well, the reason is because this binding will observe our point of interest value on tick. So because this task now implements a tick function, which is checking the value of this parameter every tick, we've now got this icon here letting us know that a task in this state is using the tick function. Now, one thing that I didn't mention in the previous video, and something that we'll explore later in the series, but I might as well just mention it briefly now, is that as of Unreal Engine 5.6, we have a new feature here called Scheduled Tick Policy. Now, what this means is that it gives us some ability to customize the tick rate within our state tree. We have three options in this drop-down here: default, allowed, and denied. Now, I don't believe there's any difference between default and allowed, but essentially what this allows us to do is to customize the tick rate within our state. So for example, now that one of our tasks is running the tick function, we can go over here and select custom tick rate and actually define a custom rate that we want the task to tick at. By default, it will tick on every frame, but we could actually set this to, for example, if we set this to 1, this will now tick every 1 second rather than every frame. Now this gives us the ability to optimize the tick within our states for better overall performance. Now under scheduled tick policy, I don't believe there's any difference between default and allowed, but if we change it to denied, it removes that option. So it denies us the ability to customize our tick rate. If we change this back to default, we're not going to worry about customizing the tick rate for now. This is something that we'll worry about in a future video, but I thought it was important to mention for your own knowledge. Moving back to our MoveTo task, we've bound our destination vector as the parameter point of interest. Target actor is something that we would assign if we want the NPC to move towards a specific target rather than a specific destination. We don't have to add a destination. We could add a target actor if we wish. Underneath target actor, we have acceptable radius. The acceptable radius is simply a threshold radius for our destination, which is considered a success for the agent to move towards. So for example, if we set this to 50, once the agent reaches within a 50 centimeter radius of the destination, our task will accept that radius as having reached our destination. We don't need to worry about anything else for now, so we'll go ahead and minimize that. And because we have more than one task and we want both tasks to finish before our state completes, we will select this drop down here and select all so that all tasks are completed before moving on from this state. Now we'll go ahead and add a transition. So we'll add a new transition rule, and on state completed, we will move to the next state, which is wait. And for this, we'll simply select the wait state. We'll add a task and simply add a delay task. And we will set this to 2 seconds. If you want, you can set a random deviation as well. So for example, if we set the duration as 2 seconds with a random deviation of 1 second, it will wait for anywhere between 1 second to 3 seconds. And when our delay task is completed, we will add a new transition rule. On state completed, we will move back to the root, which will then, of course, come back down into move to another random location. Compile and save. Now we're almost ready to implement this behavior. So we'll go back to our map, and from our content drawer, we will go to blueprints, characters, and we will drag our NPC character into the world. But you will notice if we hit play that nothing appears to be happening. And the reason is because we need to add what's called a nav mesh bounds volume. So from this panel over here, if you don't see this panel, you can go to window and then make sure that place actors is selected. And then we'll go down here to select volumes. And the volume we want is this one here, nav mesh bounds volume. We drag that out onto the world. What this is it defines areas where an NPC can navigate towards. So what we'll do is I'll press Alt-J to enter a top-down wireframe mode with the, now I still have the nav mesh selected. I'll press the W key to change to the move gizmo, and I'll move this to the center. I'll press the R key to change the scale, and I'll just scale from this bar here. So we're scaling in a 2-dimensional axis, and I'll just cover the entire map. And then I'll press Alt K, press the W key again to move this up slightly, press the R key to scale it, and we'll just scale the Z axis to completely cover the entire section. And then to go back to game view, we'll press Alt-G. Now to view the navigable areas of this nav mesh, we can press the P key on our keyboard. And once we press that, you'll now see all the navigable areas in which our NPC can navigate. Press the P key again to remove that. And now if we press play, you'll see that our NPC character is finding a random location, waiting between 1 to 3 seconds, and then finding another random location and then moving to that location. So we'll just exit out of this. And one more thing that we'll explore before we move on from this lesson is that it's always helpful to have a bit more information about what's happening with our state tree. And for that, if we go back to state tree, we can make use of a very useful task called a debug text task. If we select our move to random location, I'm going to add a new task and we will select this debug text task. Now what this does is it adds some text into our world when this particular state is running. The text I will add in this case is moving to random location. We can change the font scale if we wish. I'm going to keep it at a value of 1. We'll leave the text color as white. And one more thing we will do before we implement this is that for our reference actor input here, if we don't bind this to our context actor, what it will do is it will show the text at the world location of 000. Whereas what we want to do is we want to bind it to the location of the actor. So we'll select the binding And then under global, we'll select actor, compile and save. I'll also add another debug task to our wait state. So I'll select that. And then under tasks, we'll add a new task and then select debug text task. And this time I'll just type in waiting, and I might change the color to maybe reddish sort of color. And again, we'll bind it to the actor's location, compile and save, go back to our level and then hit play. And now what you'll see is it's adding the debug text to our screen depending on the state that our NPC is currently in. Now, I have found the debug text task very useful, particularly when debugging states, and I'm not particularly sure what state might be currently active at the moment. So we will make a lot of use of this in future videos as well. So there you have it. We've now created our NPC character and implemented some very rudimentary behavior using our state tree and our AI controller. In the next video, we're going to add sight perception to our NPC character to enable the character to change to an attack state when our player character enters the enemy's line of sight. I'm really looking forward to seeing you all in future videos. Again, please like the video, leave a comment, let me know how your learning's going, and be sure to subscribe to the channel, and I will see you in the future videos.